All right, this short video, we're going to work with compounds that have extra, and I'm use that word advisedly, extra available electrons. When we have drawn our structure and we've assigned our available electrons, and everybody on the outside, all the atoms on the outside have their octet, or if they have hydrogen, they have their bond to it. We've done that, and we do our count, and we come up and find out that we have not assigned all of the available electrons. Then the rule is to assign those electrons to the central atom in pairs. Okay, to the central atom in pairs. Now, that may, in some cases, violate the octet rule for that central atom, and we'll look at that in one of these others. Specifically, one of the compounds we're going to draw when we draw ions does that, okay? But that's okay. The rule is we've got to assign all the available electrons. We start assigning them to the peripheral elements, to the outside elements first, so that everybody out there is satisfied with either an octet or a hydrogen with 2. If that's done, and we've counted correctly, and we still have available electrons that have not been assigned, they get assigned to the central atom in pairs. So we're going to practice that on, we're going to work through that on the one you see here, PCl3, phosphorus trichloride. And then in this one, we're going to try to do 2 practices maybe, just to see if you're getting this down well. All right, so let's look at this and do our NASB. NASB. No hydrogens in PCl3 formula, so I have what? 4 atoms, each needing 8 electrons. So to draw this, if this structure was going to have all the electrons it needed, I'd need 32. All right? I'd need 32. Now, available. I have 1 phosphorus, and phosphorus sits in group 5, so it's going to bring its 5 valence electrons. And to that, I am going to add the 3 chlorines. And they're still in group 7, so they're each going to bring their 7. So 3 times 7 is 21, and 5 more is 26. So I have 26 electrons available to be used. Shared, N minus A, 32 minus 26 says I've got, what, 6 electrons shared. Bond says, what, 6 divided by 2, the shared divided by 2. So I should just put in 3 bonds in this compound. All right, central atom. If you look at your periodic table, chlorine sitting right next to fluorine, so it's got a pretty high value of electronegativity. Phosphorus is farther away, so it's probably got a lower electronegativity value, and it's the only one of its kind, so I'm going to use phosphorus as my central atom. So I'm going to draw a phosphorus. I'm going to put a chlorine and a chlorine and a chlorine. I'm going to do it in some kind of symmetrical pattern, and I'm going to draw a single bond to each one of them, just like we've learned. All right. I have used 3. This thing said I needed to use 3, so that's good. And now I need to look at my available electrons and start assigning until I get 26. All right. So if you remember what we're going to do, we're going to go up here and we're going to assign, since we got chlorines, every one of them needs 8. This chlorine in the upper left has 2 already, so I'm going to give it 6 more. So we're going to assign those in pairs. All right, the chlorine at the bottom has 2 in that bond, so I'm going to give it 6 more. Assigning it in pairs. The chlorine up here in the upper right has 2 electrons, so it needs 6 more. All right. So everybody on the outside has what they need. They have 8. 2, 4, 6, 8 there. 2. All right, so let's count what we got. 2, 4, 6, 8 have been used. 10, 12, 14, 16, 18, 20, 22, 24. I've used 24 electrons. I need to use 26, so I have 2 extra available electrons, and the rule is that those 2 have to be assigned in pairs to the central atom. So I'm going to come up here and put them in. Now, do not put 1 in. I'm going to have to erase this. Don't put 1 here and 1 here. That's not the rule that we got to follow. The rule says assign those things to the central atom in pairs and do it that way. Now, again, our final check. Does everybody have 8? This chlorine has 8. All right, this chlorine has its 8. This chlorine has its 8. And phosphorus has 8. Phosphorus has 2 in that bond, 2 more in that bond, 2 more in that bond, so that's 6. And it has that pair of electrons, so it has 8. So that is a good representation for the Lewis dot configuration of PCl3. All right? So good. We're going to do, I'm going to turn you loose. What I would like you to do next is I would like you to draw the molecule NF3, nitrogen trifluoride. I'd like you to put this on pause, go through your NASB method, and come up with a good Lewis dot representation for nitrogen trifluoride. So put this on pause and do it, and then come back and pull up the next slide. Okay, nitrogen trifluoride. Hopefully you have a molecule with a Lewis dot structure that looks like that. Nitrogen in the center, the 3 fluorines around it, each of them having 8 electrons, and one set of unpaired electrons on the nitrogen. Hopefully when you did your NASB count, 4 atoms, each needing 8, so that was 32. Available is 26. Again, nitrogen is in the 5th period, so it has 5 valence electrons. Each of the fluorines in group 7. So it's, if you do your math right, that's 26. Shared would be 6. Bonds would be 3. You chose nitrogen as your central atom because fluorine is the most electronegative element, so any other atom has to be less electronegative. You put it in the center. You put your 3 fluorines around it. You drew your single bond. You said, yep, 3 bonds is what I have. 3 bonds is what I have to show, so I'm good there. And therefore, I need to go back and start assigning until I've assigned all 26 electrons, all 26 of my available electrons. You started on each of the fluorines and gave each of them 6 more. And when you did your count, you found out you used 24 at that point. So that said you had 2 extra, 2 unassigned electrons that were available that needed to be shown in your structure. So you put them on the central atom as a pair. Good, good. Hopefully you got that. Now, if you had a little trouble with that, maybe we're going to up the ante here a little bit more with sulfur dioxide. We're going to bring a couple of things into play here. So this will be a good practice as kind of a review to this point. If you've kind of looked at the videos we've done to this point, this will incorporate the things we've done in 2 or 3 of those. So put this on pause, draw your Lewis dot structure for sulfur dioxide, SO2, and then bring this back up and let's see if you and I agree on what that structure looks like. Okay, hopefully you've done that and gotten it done, and you have a structure that looks like this right here. All right. When you did your NASB method again, you did what? No hydrogen, so 3 atoms times 8 is 24. Sulfur has 6 valence electrons. The 2 oxygens each have 6, so that's 18 available. 24 minus 8 is 6. 6 divided by 2 was 3 bonds. Pick sulfur as your central atom since it looked in our trends table. If you think about the trends of electronegativity, as I go up a group, I go towards the higher or greater electronegative element. Oxygen sits higher than sulfur, so sulfur would be less electronegative than hydrogen, or than oxygen, I'm sorry. And it's the only one of its kind, so we're going to put it in the center. We drew our oxygen atoms out there, and then we put a single bond in, right? You put that single bond and probably that one, and then you said, I've used 2, but this thing says I need to use 3, so you had to have a multiple bond in, so you went ahead and put your 3rd bond in and used those up, and then you went to assign 18 available electrons. This oxygen already had 2 with that single bond, so you gave it 6 more. This oxygen on the right-hand side had 2 bonds. It had a double bond, so it already had 4 electrons, so you gave it 4 more. And then you did a count. because both the oxygens now had 8. So you said 2, 4, 6, 8, 10, 12, 14, 16. But I have to use 18, so there have to be 2 extra electrons that I have to assign as a pair to the central atom, and you did that right there. And you check to see if everybody had 8. The left-hand oxygen has 8. The right-hand oxygen has 8. And now sulfur has 8. It has 2 in that bond. It has 4 in the double bond, and what we call a lone pair. So it has 2 there, so it has 8 electrons. That is a good representation of that. Now, there's nothing wrong if you had yours sort of exactly backwards from mine. If you had something that looked like this, that would be okay too, since it doesn't matter which side that we put the double bond on. Either one is fine. Okay? Folks, if you've gotten this, you're doing well. Because, like I said, this incorporated a couple of things. We had to have multiple bonds because we hadn't used all of them, and we had to assign a pair of electrons that were available that had not been assigned to our outside elements. So we had to apply the rule about assigning any unused available electrons to the central atom in pairs. Folks, I hope you're doing well on this. This ought to be something that we ought to be getting better at as we practice. So let's just kind of continue. We've got other videos to watch. If you haven't watched all of them, you may need to watch the ones about the ion and the one that maybe where the central atom violates the octet rule. So that's going to end this one.